Well, good afternoon, and we should get started. Welcome to the seminar today. Um, as some of you might know, as part of the Responsible AI Initiative, we have established a Distinguished Visitors Program to bring in experts in areas related to responsible AI to come and spend some time with us. And today's speaker, David Danks, is the inaugural Distinguished Visitor as part of this program. David is an international leader working at the intersection of data, AI, ethics, and policy. And that's reflected not only in his research, which spans, and I'm reading here, across philosophy, cognitive science, machine learning, and the intersections, and he has examined ethical, psychological and policy issues around AI, robotics in multiple sectors, but also through his leadership roles, right? Whether it's part of the National AI Advisory Committee that was set up by the White House, whether it's part of his work in different advisory boards, including RAI, and other work that he does in the community, the CCC and other activities, and can read his bio, but he's got a whole set of awards. So we're really delighted and to have him be part of our embedded with us for the next few days. He's going to be spending this week here, and he have additional visits in this year. So please make time to meet with him. And let me hand it over to you, David. Thank you.
Thanks so much, Manish. Thanks everybody for coming out. Hopefully the sound is okay. Apologies to the sound engineer. I will get louder as time goes on. It's really a pleasure to be here. The Responsible AI Initiative that is being built out here in Utah, both with the university, but just in fact across the whole state, is, I think, really a model for many of us who are looking to alternative ways to try to govern AI systems so that they actually are to the benefit of all rather than the benefit of just a few. So I'm delighted to get to talk to you today about responsible AI. I will say right off the bat that I wasn't quite sure what the audience was going to be or what backgrounds people would bring. So this is going to be a little bit of a fast-moving talk. So if you get bored or you think something's uninteresting, just wait 7 to 10 minutes. I'll be on to something else. I'm going to make sure to leave some time for questions. There is a reception that I'm happy to talk to people afterwards, but I will try to leave some time for questions here within this hour. So I want to start by telling a few stories to talk about why I think responsible AI becomes important, why we need to make sure that we're really thinking about the ways in which we are and are not getting AI that serves the public. So the first is from starts in 2016. So for those of you who don't know, this is one of the Uber ATG self-driving cars. I picked this particular one because you wouldn't know it necessarily, but this is sitting on a street in Pittsburgh. I spent 18 years at Carnegie Mellon before I moved to UC San Diego. And in 2016, all of a sudden, in the neighborhood I lived in, Shady Side, these cars appeared. At the same time that my eighth grade daughter was walking to school every day. And there was no public discussion. There was no information about what safety testing they had done. Yes, there were safety drivers behind the wheel, but everybody knew the safety drivers were told, try not to intervene on the system, let it make some mistakes. Let it make some mistakes is not what you want to hear when they're driving on the streets that you are walking on or you're driving on yourself. And in fact, in 2018, when there was a tragic fatality in Tempe, Arizona, the Uber ATG cars were suddenly pulled back. They stopped driving in the neighborhood for about a year, and then they showed up again. And you could also look to what's happened in San Francisco, where Waymo has been deploying, and other companies are deploying self-driving cars against the wishes of many of the people who live in the city. Of course, many of the people who live in the city want them there, right? But so these technologies are directly impacting people's lives with not necessarily a whole lot of clarity about how they're going to be governed, how they're tested, what safety even means for them. A second story. This one is going to come back later, so I'll be brief about this one. This happened pre-COVID. There was a research group, a data analytics group at a hospital that realized that they were facing enormous problems with healthcare worker burnout. People were just getting completely fried. And again, this is pre-COVID. And so you can only imagine what it is now. And they had the idea of, what if we could come up with a way of predicting who might be suffering from burnout? Who should we give, a paid shift off just to recover, or give them other ways to perhaps reduce the extent to which they're feeling burnout? Completely standard data science problem, right? You've got personnel records, you've got historical data about who suffers from burnout, who doesn't, and how do we help our employees, right? Done out of the best of intentions. Here's the part that made it, I think, a little bit less clear whether it was a good idea, is they then thought, well, it might be a really good indicator of burnout, what people post on social media. Social media feeds are public. And so if somebody uses their name on their Instagram feed, why not ingest that as part of the data also? I mean, if somebody's saying on their Instagram feed, oh my God, so exhausted, another brutal day at work, that's a pretty good indicator this person might be suffering from burnout or at risk of it. Now, of course, as the large number of chuckles indicates, there's a lot of worries about that. There's potential for privacy invasion. There's potential that you're going to chill people's speech. It changes the relationship between the employee and the employer. Lots and lots of worries. But at the initial idea that came up was in a data analytics group who said, but won't this be good? We're helping people. Why can't we just do it? Again, I'm going to come back to this story again. A third one, of course, is known to everybody, right? ChatGPT, or pick your favorite model, right? It sometimes is hard to remember that these things are only slightly more than 2 years old in terms of being part of the public consciousness. This time, 2.5 years ago, pretty much no one in the public had heard of a large language model or a GPT system. Of course, everybody, if you worked in it, you knew about them, right? These things were not a surprise when OpenAI put it out to the public. What was a surprise is that OpenAI said, go for it. We're not going to put any guardrails on this system in any real way. We're going to figure out how people want to misuse it, and then we'll put on guardrails to protect. OpenAI would not describe what they did in that way, but that's basically what they did. They put on very thin guardrails initially. Same thing happened when Meta came out with Llama 2. And we've seen this over and over. These systems deployed, in some sense, using the population as a beta tester. Now, I would suggest that all of these are examples where these would constitute things that we might not think of as responsible AI. They might be technological innovations, they might be cool technical problems or solutions, but these all, I think, are things that we would not necessarily want to count as responsible AI. But then that raises the question of, all right, so what is responsible AI, right? If these are the things we don't want, then what are the things we do want? And how do we get that? Because it's one thing if we know these are things to avoid, that can help. But if the only way to get responsible AI is, hire somebody who has 20 years of experience building responsible AI, it means we might as well just give up because it's not going to happen. And so what can we do to try and increase the likelihood that people are going to build responsible AI? So the first thing I think that's important to recognize about responsible AI is that it really is something that the issues around it and the need for particular practices arise across the AI lifecycle. And I deliberately use that term because I think it's easy to focus just on the development part. I know certainly when I'm talking with my students, undergraduate or graduate students, they think AI is, how do I go from numbers to model? That's it. And what's the math and code I use to go from numbers to model? But if you've ever actually built an AI system or been involved in it, you know that that step of development is far from the only thing. You have to identify what problem you're trying to solve in the first place. These problems do not come to us from some ground truth. We have to figure out, here's a thing that people need help with. You have to design the system. Think about what are the constraints, financial constraints, ethical constraints, legal constraints, psychological constraints. Then you can start to develop it. Then you can deploy the system. You figure out where it's going to go out into the world. You use it. right? And of course, when you deploy, the way you deploy is not always the way that it gets used. There's many cases where people have built great AI systems, then they put it out into the world and people systematically misuse it, or whether unintentionally or intentionally. We refine these things, and of course, it's all a giant feedback loop. These things are not stable in the sense of somebody comes to you and says, here's the data, produce me a model, and then that's the only role that you play. Almost always, we need to think much more broadly. And responsible AI really shows up across all of these different stages. It's not something that is just one piece of the puzzle. And to try and make that case, rather than giving you some abstract argument, I thought what I would do instead is do it as sort of proof by cases. So I'm going to give 4 case studies, 4 examples of research that we've been engaged in my group over the last 5 to 7 years, trying to come up with ways to make it more likely that we're going to get more responsible AI. Right? So I'm not giving you a definition. The philosopher in me wanted to do that, but I also figured that would put everyone to sleep, and I didn't want to do that. So what projects am I going to talk through? So one is about how you identify what are the challenges worth looking at and what are the things you need to think about. A second one is how do we get better algorithms, systems that actually do a better job of producing responsible AI systems. Third is how do we deal with bias and the biases that can result, and in particular, the ways in which it's much more complicated than you might think. And then looking at policy issues around dynamic certification and ways that we can improve the use of these systems in practice. I'll note in advance, so you may have seen on the title slide that I'm currently appointed in 3 different units at UC San Diego, data science, philosophy, and policy and strategy. And these are going to be data science, computer science, philosophy, and policy, right? So there's going to be all 3 of those elements up here to help sort of hammer home the point that this is a multidisciplinary problem. Responsible AI is not just technical, it's not just social, it's not just psychological. It touches on all of them. But I want to start with one that actually touches on all of these pieces. And this goes back to the story that I told about the use of social media feeds. Because the way that story continued is that it just so happened that I had met the director of this data analytics group at a workshop about 2 months earlier. And he thought, hey, wait a second, that person knows something about ethics. Why don't I give him a call and see if this would be a good idea for us to use the social media feeds? And so he called me and I said, no, that's a really bad idea to use these feeds, especially if you're going to use them without talking to your employees, which was the intent. Because I thought, well, it's public, we don't have to talk to our employees about it. We can just scrape these feeds. And as we talked more, what we realized is that there was a fundamental problem that he was facing in his group, which is that he had a bunch of brilliant statisticians and computer scientists who had 0 training in ethics. And so when they thought about the problems that they wanted to look at, they thought about them purely in a technical way. But when we think about the challenges in the real world that we want to deploy AI for, invariably they are multidisciplinary. You can't just take one lens to make sense of it. Any problem worth solving is going to be complex enough, you have to look at it from multiple perspectives. It's multi-stakeholder. Lots of people's voices matter. You don't just get to look at just, well, here's the people who gave me the data, whatever they say goes. You have to actually think about the employee's perspective, management's perspective, the patient's perspective, right? They should have a say because they don't want to be treated by somebody who is burned out, and on and on and on. So it's multi-stakeholder. The problems that we're trying to solve are often vague. Burnout is not a well-defined thing. Helping people avoid burnout is not a well-defined problem. If you say, what's success? We say, well, people making it through their day. It's not very useful. And in general, a lot of the problems we care about are vague in the sense that we don't know quite what counts as success. And we don't quite know the scope of the problem that we're trying to solve. You can give me data, and the data are a representation of the environment, of the population and the environment, but it's not telling me what counts as success in the problem. Moreover, the problems are always changing. Most of the real world problems where we want to use AI systems are cases where right now it's this problem, but then particularly if we deploy an AI system, now the problem's going to morph. If I'm trying to predict student success, In my classes, notice first of all, that's a vague problem. I don't know what counts as student success. Is it students make more money after they graduate? Is it they come back the next year? Is it they get a good grade in my class? Is it that they don't get a bad grade in my class, right? All of these could count as success. It's a vague problem, but it's also a changing one. Notions of student success today are, I think, pretty different than they were when I first taught, when I was first a little baby bunny assistant professor back in a lot of years ago. And so it's a constantly changing problem. We have value conflicts. What I want might be different than what the employee wants, might be different than what the management wants. Right? Value conflicts are close to ubiquitous for any interesting problem, where value conflict means the ideal system from my perspective is different from the ideal system from someone else's perspective. Right? So we have to decide, who are we giving priority to, or how do we trade off these different interests and different values that people have? And so what we need, in some ways, is not a solution to these problems. That's unlikely to happen. But what we realized when I was speaking with the data analytics group is what they really needed is they needed to know who to call and when to call. Because there are some problems that the data analytics group was working on, balancing the server loads in the hospital, that it's like, yeah, you don't need to call me with my ethics hat on. That's a problem that is sort of constrained in such a way that it's okay not to, it doesn't have the same number of features that are problematic. But other times they do. And when we talked and thought about it, what we realized is that there are many other cases, but one that was very salient to them is working in a hospital, where we have this problem. And in hospitals, there's this thing called an ethics consult. Doctors are not expected to be able to handle some of the ethical issues that might arise, for example, with end-of-life decision-making, or when there's conflict, if somebody's in a vegetative state and there's conflict amongst the family about what should be done. If you have multiple people who have a say in the medical decision-making. And so there are people whose job is that they get called to help with these kinds of ethical issues that can arise in hospitals. And doctors are not trained to solve those problems. They're trained to recognize those problems, that they're in one of these states, and to call somebody who has the expertise. So we thought what we needed to do was something like ethical triage, but for data scientists, for AI engineers. How do you know when to call? I'll be egocentric here. How do you know when to call somebody like me? Because if you're balancing server loads and it's an ordinary circumstance, you don't need to call me. If you're thinking of scraping without telling them your employees' social media feeds to put into a predictive model for burnout or other mental health issues, please call me. And so the question was, could we do that? Could we come up with a tool that was actually effective for enabling this kind of ethical triage? That people who are not trained in ethics, not that they would learn to solve ethical challenges, but that they would learn when to call for help. Because that's a much easier problem to solve than to teach 1,000 data scientists how to solve ethical problems. And so we actually did. We developed a tool. It is open source. You can use it if you want. I can provide anyone who wants a copy of it. So we developed a tool. As you can see up there, it's 8 questions. It's a very simple thing. You can do it in about 3 minutes, maybe 5 if you want to think hard about some of the questions. What's interesting is that the questions are not necessarily the ones that you might have thought. They're questions like, if your dependent, parent or child, were to be subjected to this, would it bother you? They're the kinds of questions that are actually pretty easy for people to answer. And you as a data scientist or an AI engineer don't need to understand why that is a useful diagnostic tool in order for it to function as a diagnostic tool. So you might ask, all right, how well did it work? This sounds really cool. How well did it work? So anecdotally, we have about a sample size of about 5 where it was used. It worked really well. In particular, because it forced people to think about some of these kinds of questions in advance of building the tool. Now, you might say, why is it only a sample size of 5? Well, because those samples were done in, or the cases that they went through were in December of 2019 and January of 2020. You might have heard of something that impacted hospitals about a month or 2 later. And to be blunt, the global pandemic hit. They had other stuff to worry about in the data analytics group besides this tool. And so we haven't done the follow-up studies because then I was moving to San Diego and life goes on. But we've got a sort of proof of concept. And it's actually one that I now use with my students. When I'm teaching students in data science classes, and they have to come up with their own projects, I use this tool or a slight adaptation of it to say, before you go forward thinking of starting to spec out the design for the system, check for yourself. Does this raise red flags? And one of the nice things about it, again, is that it gets people just to think about the right questions, even if they don't know how to answer questions. So that's in the design phase, how we might be able to get more responsible AI. We get people to think about the right kinds of questions. Right? Suppose you do that, okay, can we do things better with the algorithms that we use? Can we use algorithms to actually improve how responsible or ethical our AI systems are? So let me give a different kind of example. Here I'm going to switch into computer science mode. Very short? Maybe wait till the end. Yeah, thanks. So here, this is going to be computer science. So if you are used to thinking about algorithms, you can perk up. If you're not, then you can drift off. So here's a problem that happens not infrequently in AI and data science. We have multiple data sets that measure some variables in common, but other variables that are distinct. Right? So Manish measures variables 1, 2, 3. I measure variables 3, 4, 5. Right? So we've co-measured some, but we haven't measured all the same because it costs money to measure and it's a pain to measure, and so you might not do it. And here's the tricky part. In many cases, we actually cannot or we should not integrate these together into a single unified data set. So for example, we might think that, but yet we want to ask questions about things that are not co-measured. Right? So there is a data set out there that includes data on my mental health. There are data sets out there that include information about my finances. You might wonder whether your sort of financial health impacts your mental health. That's a natural question to want to ask. I really do not want there to be a data set that merges information from my bank and information from UCSD Health, simply for privacy reasons. And actually, more generally, when we look across a wide swath of cases, the questions we may want to ask questions about the relationships between factors that we cannot, or should not jointly measure on civil liberties and privacy grounds, for example. There might also be financial reasons. It might just be expensive to jointly measure. There might be measurement challenges in the sense that to measure one factor sometimes, it can mean that it changes the measurements of other things. Right? If I tell you that I'm studying this aspect, then that changes other parts of your responses. Okay, so the question that we wanted to ask is, could we still do interesting AI work in these kinds of settings? Because the alternative is what you actually frequently hear from companies, and these days also a lot of governments, which is we just need to siphon up all of the data, put it into one giant data lake. We're going to integrate, data brokers love to do this. They get data from 15 different people, 15 different companies, and find ways to merge it all together into one giant string of data about an individual, which is often quite invasive to people's privacy. Things that I would never consent to if you asked me, can I collect all these data at once? But yet they're able to assemble it. Right? So one part of better algorithms is algorithms that can help to, by their very design, potentially protect people's privacy and civil liberties, not through things like differential privacy, but by saying, let's just never combine these data sets in the first place. If we never integrate them together, then we don't have to worry about these kinds of re-identification problems, for example. So the question that we wanted to ask is, what could be learned about these never co-measured features? So more technically, the problem is, given overlapping data sets, I read it up here, and I'm particularly interested in causality, because it's not just that I want to be able to predict the impacts of financial health on mental, it's not just that I want to predict your mental health given a measure of your financial health. I want to understand the influences that arise, because if I want to take policy actions, if I want to try and improve the world, I need to know something about causality. So we were particularly interested in causality. And so this was the question that we wanted to ask: what structures are consistent with the marginal graphs of each data set? right? So if I just see these snapshots of the world, we sometimes refer to this as causal quilting. If I just see snapshots of the world, how can I stitch them together in a principled way? Right, so let me just give an example, just in case you're sitting here as a computer scientist thinking this isn't possible. You could have arbitrary connections, right? So imagine that we get these two separate understandings of the world from two different data sets. Notice that S is jointly measured in both. Sorry, S is measured in both. It's never jointly measured, right? So this tells us that we learned that A and B cause S and X cause Y. S and X are not connected causally, right? So the absence of an edge is informative here. Similarly, A and B are not causally connected. Now, what I want to know is, what can I learn about the structure involving all 5 variables, not just these 2 representations of 3 variable systems? Okay? Let me give an example just to sort of motivate some of this, right? So think about between B and X. Now imagine B and X caused X. Just imagine that. Well, then that means that there's something, namely B, that is a common cause of S, because we know B causes S, and X. But this graph tells us there's no direct connection between them, that there isn't that unobserved common cause, right? Or imagine that X caused B. Well, that tells us then that X is actually a cause of S. But again, we know it's not. So we can know just from these 2 snapshot graphs that in fact, there is no direct connection between B and X, and similarly between A and X. Even though we've never jointly measured them, if, assuming the inputs are correct, then we can draw that natural conclusion. And in fact, more generally in this particular case, there are only 6 structures over the 5 variables that are consistent with these 2 marginal graphs, with the sort of snapshots that we get. So we can actually learn quite a lot about, and there's, if you're curious, there are over 20,000 possible graphs over 5 nodes, right? It's not as though we went from 8 possibilities to 6. Right? We've actually significantly reduced the search space. And there is some stuff that's shared, and there are some differences. So we can't learn as much as if we measured all 5 variables. So there is a cost that we're having to bear by virtue of the fact, in this particular case, by virtue of the fact that we didn't jointly measure everything. But if these are my medical data and these are my financial data, I'm really glad that we're not integrating them together, and we can nonetheless learn something. So now you might be thinking, all right, yeah, but how much can you actually learn? So here's some things, and these are from, these results are from last week, so hopefully I can explain them properly. But the short version is what we're looking at here is how much, the relevant thing is, here we go. This is the one you want to see, right? So this is within the output possibilities. There's a whole bunch of different possibilities that come out. Of the ones that are common, right? They're frequent. They show up in lots of the outputs. So X causes Y in most of the outputs. What we wanted to ask, and this is on simulated data, what we wanted to ask is, what proportion of those actually are correct? And what we find, you can sort of see, these are all tall bars. That's the only thing you need to worry about at the moment, right? The fact that they're all tall bars tells us that if something is widely shared in the output set, then it's highly likely to be correct. Okay? And so, in fact, we can start to learn some things about never jointly measured factors just by looking at these snapshots. Now, we're not going to learn everything. What this is showing is how many outputs are there that we need to look at, right? So you can see in really bad cases, very dense graphs with not a lot of overlap between them, we're up at, on average 10 to the 5 output, right? I'm not going to manually inspect 10,000 graphs, or 10 to the 5 is actually 100,000 graphs. I'm not manually inspecting that, right? So, but there are others where we're down around 1 graph. If we have significant overlap between those marginal pictures, if they overlap a lot, then we actually often are getting single digits of outputs. And those are things that I can hand off to a domain scientist, or that I can bring back for modeling purposes. Again, even though there's a lot of relationships that are never jointly measured. Now, you probably can't see it in the back. You might be looking going 8 vertices. That's pretty small. That's not very many nodes. We're able to run it up to 25 node graphs. And the relevant thing here is that, again, we're getting lots of very big numbers, right? That we're getting close to 1 in terms of the accuracy of things that are shared amongst the outputs. So we can't learn everything, but we actually can learn some things. And we can know what we are learning. We have a test, namely the frequency within the output set, that is a reliable indicator of something as likely correct. So when confronted with, we've got these 5 data sets, and they're on different things, and we want to know about the relationship between things, I guess we have to merge those data sets. From an ethical responsibility point of view, no, you shouldn't, right? Because that's very invasive. It creates all kinds of risks. And what we're trying to show is that in a lot of cases, you don't have to. So you can use different algorithms, other than the standard ones people might do, in order to be able to do AI without having to infringe upon people's privacy, at least in those ways. No companies like Meta are, to the best of my knowledge, not using these kinds of methods, which is unfortunate. All right.
So is this like causing the same problem that if moved it?
What do you mean?
So can you not make the same inferences about people if or did you avoid it?
So what comes out of this is not information at the individual level, it's information at the group level. Now, depending on the nature of the group, you might be able to do reverse inference to interpolate what the values potentially are, except part of the challenge, it turns out that unless you're willing to make really strong assumptions, the error bars on your understanding of basically your error bars on the parameter estimates are really big, unless you're going to make very strong assumptions. So I can know that, for example, financial health matters for mental health, but I am not going to be able to get a clear estimate of the strength of that relationship, which means that any imputation or interpolation I do is going to be very, very noisy. Yeah.
So if we have more number of graphs, are we able to, if we able to get
Yeah, so we do. So the worry is, if I've got 100,000 graphs, how do I intelligently do the minimal number of minimally invasive experiments or studies in order to reduce that down to a tractable number? Yeah, so that's other work we've got, where we've got it takes a couple of seconds to run kind of algorithm to come up with the sequence of studies that you would do conditionally in order to most efficiently basically fracture that into, in order to find a set of a size that you get to say, which could be the singleton, if you want to get down to the one. Yeah. Okay. Third one, bias mitigation. So I take it many of you in this room, if you are connected at all with responsible AI, you've probably heard the term algorithmic bias. This idea that algorithms can have outputs, in fact, our data as well, can have outputs or implications that the easy way to think about it is that it can replicate the biases that we observe in historical practices, right? So if we look at something like recidivism, which is supposed to be the likelihood that somebody who's released from prison will commit a new crime. But how do we actually measure it? We actually measure recidivism as the probability that somebody released from prison will be rearrested. So if you are in most parts of the United States where there are racially biased policing practices, that the measurement, namely probability of rearrest, is going to be a biased indicator of the thing we care about, namely probability of commission of a crime. And so that can then get just sort of baked into things like the COMPAS algorithm, if you're thinking about recidivism prediction. Now, almost all the discussions of algorithmic bias focus on the notion of bias as a property either of the data or the model, right? So they think about it as it's a technical thing. So it's differential false positive rates on the basis between groups defined by a protected attribute, to use more legalistic language. So it would be a biased algorithm if your diagnostic AI system had differential rates of false positives in men and women. Except notice that if I'm doing something to predict, say, diagnose prostate cancer or breast cancer, we might actually think it would not be a problem if I have differential false positive rates between men and women. So just the mere presence of that disparity is not in and of itself the problem. The bias has got to be something more. It's got to be something about the reason why there's the disparity or the implication of the disparity. So we have to be careful in that sense. We can't just look at the observed statistics and thereby infer bias, at least not problematic bias we need to mitigate. It also goes in the other direction. Just because I come up with an algorithm that is unbiased by some measure does not mean it's going to work the ways that we want. So an excellent, though really depressing example of this is work done by Megan Stevenson, most notably. What she did is she looked at the use of algorithms for bail recommendations. So somebody is arrested, they go before a judge, and they can be released from jail pending their trial if they put up some bail. But of course, the amount they put up could be $0, called being released on your own recognizance. And it will probably surprise no one in this room to learn that historically bail decisions by judges are highly biased along racial, socioeconomic, and gender grounds. Okay, and where you look at sort of roughly speaking, all else being equal, if you have darker skin, male, or poorer, all three of those factors mean that the amount you're supposed to pay in bail goes up. Okay, so this is sort of an obvious problem for computer scientists who work on algorithmic bias to get really interested in, because you've got lots of data. We know what the bail decision was. We know the facts of the cases. Do a little bit of NLP and you can extract all of it. We know whether the person came back. So we've got all of this information to make better bail recommendations. And so various groups have come up with bail recommendation algorithms that are, by all the standard statistical measures applied to the algorithm itself, completely unbiased. I mean, they are as unbiased as you could ever hope to have. And so these systems are out there now. They are mandated that you have to look at them in certain conditions in places like Pennsylvania, and where Stevenson did her work, namely Kentucky. You cannot compel a judge to follow the direction of the algorithm. Okay? So all state and federal judges in the United States, the salient court case happened in Wisconsin State Court, but they all agree that you can't, the local legislature, whether federal or state, cannot compel a judge to follow a bail recommendation algorithm. They have to leave room for judicial discretion. So Stevenson said, okay, let's look and see what happens with the bail decisions. They've got this system that makes good recommendations, good in the sense of unbiased. These are the ones that they should follow. What makes this a very depressing story is, as you might guess, the judges overrule the algorithm, the bail recommendation algorithm, pretty much exactly in the ways that reintroduce all the old biases. The cases where, no, I know better, just so happen to be the ones that involve the black or brown, male, poor defendants. So what we thought about when we looked at this is we said, well, there's an important sense in which maybe algorithmic bias is a property or measure of the algorithm, but who cares? What matters is the harm being done to people. And so what we have been looking at is the ways in which bias depends on human and AI interactions. It's not just a property of the algorithm, it also depends on how it's used. Now, what this leads to is a very tricky question, which is, if I recognize this as a human AI interaction problem, when should my algorithm compensate for the biases we know that humans have? To put it in the terms of the Stevenson paper, when, if ever, should the algorithm, the bail recommendation algorithm, lower its recommendation on the expectation that the judge is going to inflate it back up. Now, let me emphasize, there are cases where we think it's actually intuitively, where it's sort of intuitively easy and obvious what the answer is. In safety critical systems, HCI people do, the human computer interaction folks, interface designers, do this all the time. You regularly have features of your interface that are designed to compensate for example, human perceptual biases. We know that humans are not perfect information processors, so we're going to structure the interface so that they get the right information to take actions. And sometimes that means that you have information that has been distorted in certain ways to reflect, because you know what, the compensation, you're compensating for the human biases, okay? So we think that that's fine. There are other kinds of intuitively easy cases. I think it would be unethical for example, my Apple Watch to decide, David's getting a little heavy these days. We're going to say he's only done 8,000 steps when he's really done 10,000, because then he'll be tricked into to walking a little more. That would clearly be unethical. Okay? But there's also a lot of really hard cases. So you're a doctor and you've got a diagnostic AI system. Anyone who's worked with healthcare data, almost anyone who's worked with healthcare data, discovers that there are various kinds of biases in healthcare systems. There's sort of well-known problems under diagnosis of particular conditions in particular groups, for example. So should my diagnostic AI system say that somebody is sicker than they really are to compensate for the fact that that doctors underdiagnose this condition? That one strikes me as not quite so obvious. I mean, it feels wrong, but I'm not quite sure why. I mean, we're in the safety, we're in the realm potentially of people's life and death. Shouldn't the system just do whatever it takes to help people out? Or for the professors in the room, or those who are involved in grading. I don't know what learning management system you all use here, Canvas, that kind of thing. Canvas, I'm getting nods. Right, so Canvas is trying to roll out AI. They can't do weighted columns in their grade book, but they're rolling out AI systems to help us. Priorities. But they're rolling it out, and they want AI systems in part to help with grading. Now, they know that no system is ever going to be, that people are not going to turn over grading of papers, of essays to an AI. But, if the AI could tell me this is, give me a rough grade, and then I could fine tune it, I could read more quickly, be like, yeah, that's a B+ paper. Wouldn't that be, I'm lazy, sure, that would be nice. The challenge is also that we know that professors tend to be sensitive to attributes that are not necessarily relevant to the grade. So when I'm teaching philosophy classes, it's sort of well known that in philosophy, people are influenced by the fluidity and clarity of the writing, even if it's a bad argument. So philosophers will typically tell you what we care about is the quality of the argument. But if it's written really nicely, even if it's a bad argument, you can't help it, right? And there's lots of cognitive reasons why, having to do with how we think about things that are easy to understand. So the question becomes, should Canvas's AI say that paper that it thinks is an A- on because of the quality of the arguments, but it knows it's really beautifully written? Should it say it's a B+ on the assumption that I'm gonna go, no, come on, it's not B+, that's an A-. These kinds of compensation, again, it's not obvious to me. I mean, I want the students to get the grade they should have, and I know I'm fallible. So should I want an AI to be trying to compensate for my fallibility? So you might say, well, all right, this is nice, but it's all academic in the pejorative sense, in the sense that, the only way this is going to happen, this kind of compensation, is if it's a deliberate design choice by the AI engineer, and no AI engineer is going to do that. Right, that would be substituting their judgment for others. They're just going to follow the data and let somebody else worry about that. You might have thought that the problem is that also provably this kind of compensation will happen if you have a closed loop system. So if you have a diagnostic AI that finds out whether its diagnostic judgments were correct, and so it can learn, standard reinforcement learning kinds of mechanisms, provably it will learn to compensate for the human bias. So it will learn to overestimate how bad somebody's illness is. If you think of it as human-machine teaming, this is the way a lot of people want to talk about AI now, we're teaming together. If you have coordinated activities and the incentives are only mostly aligned, so we aren't perfectly aligned, success for me is not exactly the same as success for the system. For example, success for me as a grader, as an instructor, is not just giving the right grade, but it's also that I I was the one who gave the grade and I know what I'm doing, right? Whereas the AI only cares about giving the right grade, and as much as that exists, provably it will learn to compensate for me. If we think of it as a sequential gain, if you want to use game theory, provably the Nash equilibrium involves compensation, right? So the point of the technical work is just to say, this will happen even if you don't want it to. There's a high probability that you're going to get compensation. So in the interest of time, I'm not going to bore you with the philosophical analysis. We have a whole philosophical analysis of the conditions under which it is ethically permissible to compensate. These are not impossible conditions, but they are pretty stringent conditions. So we don't think that compensation is usually the right thing to do, but there are conditions in which it might be a kind of thing of last resort. And this leads to various implications, both on the technical side, which is in your model training, you need to think about what are the organizational and psychological contexts in which this system is supposed to be deployed. That's something you should think about all the way back in model training, not just after the fact, because you might not be able to correct things after the fact. Getting it right in the long term can create risks of people rejecting the AI system if they find out that it's been lying to them, for example. And all kinds of policy implications. Everyone wants to focus on outcome-based governance nowadays. Let's not try and govern the AI, let's govern what the AI does. But that actually doesn't work very well. You can't just show up with outcome-based governance at the very last step of the process. Okay. All right, one last piece, and this piece is about how do we govern these systems once they're out in the wild. So right now we're seeing the emergence of a lot of certification programs. This is in the state of California, the Public Utilities Commission. They're the ones who certified that taxis can be self-driving in San Francisco and Los Angeles. Interestingly, you'll notice that's not the Department of Motor Vehicles. The DMV has not certified self-driving cars to function autonomously, but if they're functioning as taxis, they fall under a different administrative entity, and that they said yes. So they can function as taxis, but if you don't pay them money, you can't use them in self-driving modes. Welcome to the joys of policy. And we're increasingly seeing a whole ecosystem show up around testing and certification. Companies that they would love to come and sell you a certification process or to train your people in how to do it. The problem is that the normal ways that we certify things like cars or even a lot of medical devices basically don't work when you've got AI systems. They aren't sensitive to the kinds of complexities that show up when you have these systems deployed out in the world. Most of our certification systems assume a much more constrained or closed world, and a world that is non-stationary they tend not to be good at. And the core problem here is that, in fact, AI should surprise us. We don't want AI that never surprises us. If we knew exactly what the AI should do in every case, we don't need AI. We just code it up to do that. We want AI systems to discover novel solutions that we go, wow, that's brilliant. I can't believe I didn't think of that. That's part of why we think, a system like AlphaGo, the Go playing system from 5 years ago, 6 years ago now, is so incredible. It found strategies that we humans had never found in the history of playing Go, or we never bothered to write down. Right? We want it to surprise us, but if it surprises us, then how do we know that it's matching our values? How do we know that it's actually doing the things we want it to do? I want a self-driving car to drive safely. What does that mean? What kinds of surprises are acceptable with that? And so for these reasons, the standard ways that we certify systems, for the most part, the way we certify technical systems just doesn't work. The alternative that we've been trying to argue for, we were starting to make some headway, but after the changes in DC over the last 3 weeks, I'm a lot less optimistic that this is going to happen, but in any case, is developing a way of doing dynamic certification. And the big core idea of dynamic certification is, probably the best known, it isn't exactly a dynamic certification system, but it's close enough, is the way that we certify pharmaceutical agents. We don't just say, here's a new drug, cool, anybody can buy it anywhere. We first say it can be used under these very tight conditions for these purposes under supervision of somebody who is an informed expert. And then as we learn more about the side effects, about the ways in which it might be useful, Just think about everything that's happened with Ozempic and similar kinds of drugs where we're learning, oh, wait a second, maybe we want to allow it for this, maybe we want to allow it for that, maybe we need to be careful about this side effect. And we dynamically, and we here means the FDA, of course, dynamically over time alter the context, uses, and supervision that's sort of embedded in the certification. We change as we learn. And so, and of course, we pull things back about hormone replacement therapy and the ways in which that we pulled back some of the certification of it in terms of use cases in postmenopausal or menopausal and postmenopausal women. And so the idea is that this, we think, is what needs to happen with AI systems. We need to not simply toss them out in the world unconstrained. We also need to not think of certification as I put a stamp on it that, yep, now you can use it wherever you want. If it just passes these tests, then we're okay to go, which is, for example, the approach that that NHTSA, the National Highway Transportation Safety Administration, has proposed for self-driving cars. Is basically that just as a human goes and does a driver's test, that there would be a driver's test for self-driving cars. There'd be a course, and if they can pass it successfully, then they're licensed to use anywhere, anytime. This, we think, would be a big mistake. So the challenge, of course, is how do you actually have a principled set of practices and framework? I'm not going to go into the details, but we've developed a whole framework for how this could be done, who bears responsibilities at various times, and we've shown how to deploy, how to use it for, this is looking at autonomous delivery, aerial delivery drones that are being beta tested in part of Austin, Texas, where we've shown how you can use it to iteratively learn and improve formal models of the behavior of the system so that you can actually even have, in certain cases, provability guarantees, but learning dynamically which real world contexts correspond to the context for the provability guarantees. Okay? So this is one where we haven't just come up with sort of an vaporware, but we're actually trying to implement the practices and learn, to use the horrible Silicon Valley phrase, we are trying to eat our own dog food for some autonomous drone development that collaborators at Texas are trying to do. The next one that we're going to be doing is there's going to be a fleet of autonomous scooters being deployed at UC San Diego. I don't know if you all have scooters, if they are the bane of your existence in Utah, like they are at UCSD, the little two-wheel, electric ones. And the problem we have at UCSD, as happens in most places, is that students will ride them uphill, but then they'll walk downhill. And so they accumulate. And so some folks want to be able to have it that if they've sat there for long enough, they can reposition themselves autonomously. So we've been encouraging them to let us come be a part of that work because it's the only way to get buy-in from the students and administration. So, all right, so a bunch of case studies, probably completely overwhelming, but I wanted to deliberately show the ways in which responsible AI is not a quick fix. There is no silver bullet, just do this one thing and all of a sudden our AI will be responsible. It's not going to be solved if we only had AI audits, then we would be responsible. If we only had explainable AI, then it would be responsible. There is no clean fix. It arises, the responsibility of an AI system arises because of decisions you're making across the entire life cycle. And we need to look to a whole new set of practices, processes, algorithms, and governance tools to be able to make sense of it. And in fact, what I really would want to do is push back against this whole framing that there's responsible AI and there's regular AI. I think that's the wrong way to think about it. I think we need to think about it as there's AI and then there's irresponsible AI. Because if you're building an AI system, you are making choices about how ethical, value-centered, responsible it's going to be. Even if you thought, I'm just going from numbers to model, you're not. You are making ethical choices. It's okay. We all are doing it. You can't help but make the ethical choices. It's not like this is an optional thing. And I think we need to try to rebrand things, not as, sorry to the name of the initiative, but I think the goal should not be to have responsible AI. The goal should be to stop having so much irresponsible AI. But to do that, we're going to have to look at choices across the life cycle, but there are opportunities to do better. Try to give you an indication of all the different kinds of things, and this is just the work that my group is doing. There's dozens of groups trying to do similar sorts of things. It's not an unsolved problem, but it's also one that we're very much doing in progress. So with that, I'll say thank you, and thanks to my snapshot of the collaborators. And apologies that I didn't leave as much time as I meant to.
Okay, a bunch of questions. I know we need to have his hand up first. Let me start with him.
So you showed us the picture, just.
Yeah.
I'm happy to do it, and I was wondering, it seems difficult for people to make, to want to make better choices and don't know, how to go about their actions. Do you think that's a really big issue, or is there a bigger issue of people who are genuinely uninterested in making good choices?
I think that most people don't want to hurt other people, but they think that taking the time to figure out how to do things in a more ethical and responsible way, they think it's going to take way too much time, or they think, I just don't know how to do that, so I'll just do my piece of it and leave it to somebody else. So I think that most people, this is an empirical statement, maybe I'm wrong. I think most people, if you said, here's a way that you can be sure that you can have a lot of confidence that you're doing things in a better way. It will take you 3 minutes of upfront time and then maybe a subsequent 30 to 60-minute conversation. Maybe. The optimist in me is coming out. I believe that lots of people and lots of companies would be perfectly happy to do this. What people run up against is they think that in order to do responsible AI, it's going to take me 6 months longer to get my product out the door. So this is also part of the reason I think we need to do some rebranding around you're being irresponsible if you're rushing something to market. Another thing I'll say to maybe give a further argument for the plausibility of this is we're now seeing the emergence of the first studies trying to calculate the return on investment. Because that's the best thing with businesses, to be able to say, look, this will make you money. And anecdotally, you can argue that there's reason to think that. I mean, Apple has made billions of dollars because they can charge a design premium. It's not that their hardware or software is any better, it's easier. And so their investment in design has made it so that they can charge a lot more. And the early return on things from a research group at IBM and Notre Dame is that, in fact, there is a positive ROI on doing ethical and responsible AI. The reason basically is you catch a lot more issues in the design phase when it's really cheap to fix them. Whereas when you take a life cycle approach, if you wait and only discover the problem once you've deployed it, then it's a lot more expensive. So that's my optimistic hope.
Yeah. Okay. So I was curious when you were talking about like the, management of data and how to ethically try to keep things separate from each other.
Yes.
So you don't have this re-identification problem. Something that I don't think that I work specifically in like a biosignals, applying machine learning to like biological signals, like an ECG off your smartwatch. Okay. And something that I think is interesting is we're learning we can identify more and more things from that ECG. Mm-hmm. So at some point, it becomes like a fingerprint. The smallest piece of data that we work with is now identifiable. And what do we do in that scenario when like we can't divide it from its identifiable parts any longer? The smallest quantum of data is now an identifiable piece.
Now, at that point, I think we need to start looking into things like using differential privacy enhanced algorithms that make it so that, roughly speaking, you can't figure out things from the model that is learned. You can't figure out anything about any particular individual. There's cost to using those kinds of algorithms, both in terms of compute and accuracy, but also a lot of studies that are suggesting that those costs are much smaller than we might have worried that they would be. The methods that we've been developing are not going to work in those cases. I tend to spend more of my time on sort of the coarse biomedical data, like EHR level and up, or socioeconomic data where these sorts of issues, the sort of issue you're describing doesn't come up as much. I think that comes back to we need to have a bunch of tools. We need to not just think that, if we all just did this one thing, then we'd be okay. So yes, you're right that this isn't going to solve it, but I think there are other things that could go a long way.
First, thank you very much. This has been a great talk, and I think this is a great kickoff to the whole initiative. I think you've set a great framework for this. Now, after all that positive talk, I'm going to question one of your fundamental premises that AI should surprise us. And I would argue that in many scenarios, like artificial car or self-driving cars and medical algorithms, it shouldn't surprise us unless we're naive. So I want a diagnosis from a medical device that represents the current state of the art of bona fide, experienced experts. I don't want actually surprises, except in my little narrow context that I don't know all this stuff. And so I'm not sure that this starting point that AI should surprise us puts us in a good place when it comes to validating, testing, and building confidence in important algorithms like medical diagnostic algorithms and self-driving cars.
So I understand what you're saying, and you're right to push back. I deliberately said it in a provocative way. At the same time, I think if I know here's what clinicians do, they look at these things, and here's the ways in which they integrate that together, why am I looking at any large scale data? I just do an old school expert system, clinical decision support system, which I wouldn't call AI, right? I just code it in and I go. I was thinking about AI in the sense where we don't know exactly the right answer. So a self-driving car, do I want it to surprise me? Well, kind of, yes. I want it to be able to find new solutions to problems, to be able to dynamically find me a new route because a fire truck is in the way and it's able to figure out a way to do it. Now, the challenge is how do we balance that against, we also don't want it to cause accidents.
Right.
And here, part of the challenge is that specifying those success conditions, we can't just say, here's what you do. Anyone who's ever tried to teach somebody else to drive knows you cannot give them a set of if-then rules.
Right.
But we also don't have a clear success condition because, we wanted to get us there in a timely manner, but don't be too reckless about it, right? And so how do you think through the trade-offs of when is it okay to go a little faster or do we need to go a bit slower? What is an undue risk that you've created for the passenger or for the other drivers or pedestrians on the road, right? All these kinds of things. I would say this is a case where we don't know exactly, we can't just code it in the way that we could with some of the diagnostic.
Yeah.
But even in the diagnosis, right? If I'm getting a bunch of images of lungs, I would like it to surprise me in the sense that it finds, actually, here's this marker of early stage cancer that you human might have missed. Just as AlphaGo found a new strategy for certain things that the human Go masters had not figured out.
Yeah, two things. I mean, one is that it's impossible to code up most complex clinical conditions. There are just too many various ways. And I see the potential of AI as getting around some of those limitations. We don't know all the causal relationships because we don't understand physiology. I'm a physiologist, so I'm the first to say we don't understand the physiology. AI gives us a way to create relationships with a certain level of confidence in them that can identify what are realistic features. And when you talk to physicians about the use of AI, they love it because it can sort out the easy cases for them. It can find it's just an efficiency question for them. So as long as it's replicating their judgment in a more time-effective manner, that leaves them more time to deal with the difficult cases and maybe even talk to their patients more and do these. So there are other goals here than to have AI surprises. And I would be hesitant to go to my clinical colleagues and say, oh, by the way, that new AI algorithm we're trying out, it's going to surprise you.
So yeah, there certainly is a rhetorical question of how you pitch it to your colleagues. I will say, I think even in those cases, if you said to them, there are cases you might think are easy, but it's going to flag them as hard, maybe give a second thought to it. That's a different kind of surprise, right? This thing that you thought was easy, actually, it's telling you there's something. I would like an AI system that can help me be better at my job. And the better at my job is going to depend in part on flagging things that I would have gotten wrong. And so that's a kind of surprise. So if we want to pull back to that, happy to. Yeah.
Hi, I'm wondering how much you think these techniques and efforts can overcome bad policy, for lack of a better term. For instance, you mentioned data brokers in your talk. Like, there's already bad policy there. Those data are already out there. Is there anything we can do to put the genie back in the bottle, so to speak, or with these techniques? Or
There, I mean, this goes back to the earlier question of sort of, what do you do with unscrupulous people? And there are lots of genies that are out of bottles that are never going back in. There are things that should have happened 10, 15 years ago, bills introduced in Congress that never passed. And so there is a certain amount of what do we do now? I don't think that it's hopeless. I don't think that everything's out of the bottle. And I think that the reaction and responses and efforts to create some kinds of governance policies around foundation models, large language models, and similar sorts of things, is indicative of a recognition that things are getting, there still are frontiers that maybe we could do it better this time. Things like the possibility that, you know, the signal coming off of this watch actually is this, you know, is a fingerprint, that my ECG, EKG is a fingerprint kind of thing. That, I think there still are frontiers that we could make it harder to leap past. I'm not terribly optimistic right now. There's been a dramatic shift in Washington, D.C. People who are much more libertarian are now the loud voices. And a lot of the people who were working on governance things in DC at the federal level have left. And so, meanwhile, you know, Europe is talking about whether they need to back away from the AI Act. They already had created some loopholes, and now it's sort of, are those loopholes going to render it pointless? So I do worry a lot. The optimist in me says, but you got to keep trying. It's not, I can't give up hope yet. How's that for a happy summary? Sorry, I can't, you know, be more optimistic about it.
So what's the role, do you think, of uncertainty quantification in those core algorithms? Because, you know, for a much a potentially thorny problem like the design of nuclear weapons, uncertainty quantification plays a big role, along with all the ethical dimensions that you talked about, and, you know, certification and all those other things. So there is a, you know, at the heart of this is a mathematical algorithm. Or in many of these cases, whether whether we want to choose to examine that or not. And so shouldn't we be putting extra emphasis perhaps on thinking about that algorithm, telling us how good it is?
So I do think that algorithms, basically, algorithms being able to tell us their confidence is really important. Lots of the models that we're building right now give the best answer the model can come up with without saying, but without giving any way for the model to essentially say, look, this is the best answer, but it's a terrible answer. Hey, you know, ignore this. So I think that is a huge problem. I would push back against when you said at the heart of this is an algorithm. Well, sort of, right? At the heart of this is a system that involves humans, organizations, algorithms, and a whole lot of other pieces. And the reason I emphasize that is because it might be that a better way in some cases to approach it would be to teach the humans, look, don't trust the system in these cases, right? So there are other kinds of contexts in which what we do is we teach people when they should, you know, or we put in practices where we say, you're not allowed to use the system in this context because we think it's not necessarily going to be great. And so instead of having the system be able to say, don't listen to me, we have the humans. And the reason I think that that's important is because sometimes the focus on uncertainty quantification then gets coupled with things where, for example, it's a self-driving car that suddenly says, I'm uncertain, human take over. When we know that it takes 7 to 10 seconds to reestablish situational awareness, a lot can go wrong in 7 to 10 seconds when you're going 75 miles an hour. And so while I think it's an important tool in the toolbox, and it is absolutely an understudied tool in the toolbox, I think it needs to be used in an intelligent way with lots of other tools as well.
Thank you.
Well, join me in thanking David.